Good morning, students. Good morning, students. Now we came to last subtopic in first unit. So in this class today, I will explain clearly process water for brewery industries and fertilizers. Guys, here fertilizers. Actually, just first I will explain fertilizers. Fertilizers can be grouped into nitrogenous and urea, ammonium sulfate, and ammonium nitrate, and ammonium chloride, and phosphoric. Superphosphates, complex, and ammonium phosphate, and ammonium sulfate, um, sulfate phosphate. And the potassic and the chemicals required in the production of these fertilizers are mainly sulfuric acid, nitric acid, naphtha, carbon dioxide, and phosphoric acid. It is convenient for the industry to produce these acids in-house. Raw chemicals required are generally produced during the manufacture of main products. For example, anhydrous ammonia is reacted with sulfuric acid, usually obtained as byproduct from other manufacturing plants. Gypsum obtained from phosphatic fertilizers manufacture is reacted with ammonia and carbon dioxide from ammonia plant. Calcium sulfate produced during the manufacture of superphosphate is used in producing ammonium sulfate. Here, a fuel manufacturing process, ammonium synthesis. Here, a mixture of pure nitrogen and pure hydrogen in a proportion of 1 is to 3 by volume is compressed under 200 atmospheric pressure and passed through a chamber heated to 500 to 550 degrees centigrade, containing finally divided iron, which act as a catalyst, and molybdenum, which acts as a promoter. Nitrogen combines with the hydrogen to form ammonia. The gases, the gases containing ammonia and unreacted nitrogen and hydrogen are cooled under pressure. When ammonia is liquefied with the other two gases are recycled to the reaction chamber to get more ammonia. The reaction is exothermic. Ammonia thus generated is used in manufacture of urea. Next, urea synthesis. Naphtha or natural gas is treated with steam and hot air to produce carbon monoxide, carbon dioxide, and hydrogen. Carbon dioxide is separated from the mixture and is sent to the urea synthesis plant. Separation is done using potassium carbonate, ethanolamine, uh, di- diethylamine, and caustic soda. Ammonia from ammonia synthesis plant is reacted with carbon dioxide to form urea. The liquid is filtered and subjected to vacuum crystallization. The crystals are separated by centrifugation, dried, and remelted. The molten urea is pumped to the top of a filling tower and is spread in it against a current of hot air. Spherical pills of urea are formed at the bottom of the tower from where they are collected. Hydrogen produced from naphtha is sent to the ammonia synthesis plant, while carbon monoxide is oxidized to carbon dioxide. The manufacturing flow sheet is shown in figure 16.1. Here, phosphoric acid. Phosphate rock or fluorophytite is reacted with sulfuric acid to form phosphoric acid. An important byproduct of this step is hydrofluoric acid (HF). It combines with silica to form uh, fluosilicic acid H2SiF6. Another byproduct is calcium sulfate sludge, which is used to form ammonium sulfate. Here, the next one is the ammonium sulfate. Reaction between ammonia and sulfuric acid gives ammonium sulfate alternatively. Calcium sulfate sludge from phosphoric acid plant can be reacted with ammonium carbonate to produce ammonium sulfate and calcium carbonate, which can be used in the manufacture of cement. అన్నయ్య దగ్గర ఉంది తెలుపు అన్నయ్య ఇస్తాడు అన్నయ్య దగ్గర ఉంది అరే వాడిని బాల్ ఇయ్యమ్మా అన్నయ్యకి అరే తమిళనాడు బాల్ ఇద్దాను అమ్మా తమిళనాడు బాల్ ఇద్దాను తమిళనాడు బాల్ ఆడుకుంటాడు అది తీసుకో అందులో బాగా ఇక్కడ పడుతుంది అమ్మాయికి అన్నం పెడతావా ఇంకెంత అన్నం పెట్టి ముందు బాబు బాబున్నా I'm sorry for interrupt you guys. Now, diammonium phosphate. Phosphoric acid is neutralized with ammonia and ammonium phosphate slurry so formed is granulated and ammonium sulfate is added to the slurry before granulation to get ammonium sulfate phosphate. Here, and ammonium sulfate, the reaction between ammonia and sulfuric acid gives ammonium sulfate. Alternatively, calcium sulfate sludge from phosphoric acid plant can be reacted with ammonium carbonate to produce ammonium sulfate and calcium carbonate, which can be used in manufacturing of cement. Here, here guys, sources of wastewater in the fertilizers is source of sources of wastewater streams are process water, process intermediates, final products, and oil bearing waste from compressor house and boiler house, wash water from gas scrubbing towers. This is urea synthesis. This is the urea synthesis map. Regeneration and rinse waters from demineralization plant, cooling tower and boiler blowdowns. Next, phenols and canides. If ammonia is extracted from ammonical liquor of coke ovens. Average composition of wastewater from a fertilizer manufacturing plant is given here. The above values are all except pH are um, the except pH are in milligram per liter. pH 7.5 to 9.5. Total solids 5400 mg per liter. Ammonium nitrogen 700 milligram per liter. Urea nitrogen 600 milligram per liter. Phosphate 75 milligram per liter. Fluoride 15 milligram per liter. Arsenic 1.5 milligram per liter. Uh, these characteristics vary over a wide range, depending on the raw materials used, method of manufacture, housekeeping practices followed, reuse and recrystalline practices followed, if any. And disposal of wastewater. Here, methods of disposal include the following: disposal at sea. Minimum treatment required before disposal is removal of components which could damage, corrode, or or form incrustations in the pumps, piping, and the outfall. In addition, a thorough study of ocean currents and their mixing characteristics is required to decide the length of the outfall. Disposal into river, treatment required for removal of toxic substances to avoid fish kills, prevent deterioration of downstream water supplies, avoid eutrophication. Disposal on land, removal of pollutants harmful to soil organisms, and reduction of total dissolved solids to loss to less than 2100 milligram per liter. This is difficult to achieve except by dilution. Further, the land required would range between 10 and 20 hectare per 1000 meter cube for diluted wastewater. The dilution ratio ranging between 3 and 4, so this alternative would be feasible if adequate land and dilution water were available. Guys, actually wastewater process for fertilizers I think is enough. Now I can jump into the wastewater process in Bavaria industries. Guys, here Breweries Industries wastewater process for breweries industries. Breweries make beer from grains like barley in two stages. Preparation of malt from the grain, in which the grains are steeped to remove color. They are then made to support under aerobic conditions. The grain is then dried, spots are screened, and the grain is transported to the brewing section. The malt is treated with hot water, which turns it into wort, and the starch in it is uh, converted into sugar by boiling with hops. Hops contain resins which dissolve in the wort and contribute the typical bitter taste to the beer. The resins also act as preservatives against the growth of bacteria. The root is then filtered and cooled. The filtrate is inoculated with a suspension of yeast, which ferments the sugar to alcohol at the end of the fermentation. The yeast and malt residue is filtered and the beer is carbonated before packing. Liquid waste originate in the malt house as well as in the brewery. Malt house waste contains high concentration of dissolved organic solids and low suspended solids. This waste is usually alkaline in nature. The brewery produces waste in the form of fermentation residue, which is usually acidic in nature. In addition, waste from floor and equipment washing, yeast preparation, cooling water are also produced. Composition of malt houses and brewery waste is given table 12.5. Here, composition of malt house and brewery waste. Uh, in malt house waste, pH is 6.9 to 9.5, but in brewery waste, 4.0 to 7.0 pH. And biological BOD, biological oxygen demand is in malt house waste is 20 to 204, in Bravery waste is 70 to 3000. Total solids 428 to 700 in house waste, and in Bravery waste 272 to 2724, and suspended solids 22 339 mg per liter, but as the same case in the Bravery waste, 16 to 516 milligram per liter. Total nitrogen 14 milligram per liter to 56 milligram per liter at malt house waste, but here in Bravery waste 7 milligram per liter to 42 milligram per liter. But here again, just we want to treatment of wastewater. Bravery wastes are less strong than, sorry guys, Bravery wastes are less strong than spent wash from distilleries and can therefore be subjected to aerobic treatment in the form of two-stage activated sludge process or trickling filtration. The BOD removal of 90 to 94% can be achieved if adequate land is available. The waste may be neutralized and used for broad irrigation. Instant at all used a pilot scale crosses flow ultrafiltration membrane anaerobic reactor system to study microbial changes during startup and steady state conditions. When treating Bravery waste, the achieved 97% COD removal efficiency at a COD loading of 28.5 kg per meter cube per a day. A survey was conducted by Mino to identify pheromonatus microorganisms in activated sludge plants. A gram-positive, Neisser negative filament resembling both micro-thick sap and Nostocorida li- limicola was predominant in the plant, treating Bravery waste. Anderson et al. Investigated the microbial kinetics of a cross-flow all-filtration membrane anaerobic reactor system treating Bravery wastewater at four different MLVSS values ranging from 10 to 15 to 40 to 50 gram per liter. Values obtained were maximum specific growth rate 0.022 day and growth yield 0.38 gram per VSSGM and decay coefficient 0.0037 day and half saturation coefficient 390 milligram per COD per M. Pilot and full-scale data were presented by Haring ETL for treatment of a Bravery waste with COD of 10,000 milligram per liter in a UASB reactor, followed by submerged aerobic fixed film reactor. Pilot test showed COD removals of 93% for the UASB loaded at 8.9 kg meter cube per a day and 64% for the aerobic system loaded at 0.8 kg COD meter cube per a day. Lil subjected an aerobic upflow filter to treatment of Bravery waste of 8,000 milligram per liter. COD under mesophilic conditions, they obtained 96% COD removal after a 6-month startup period. The average gas produced was 7.1 meter cube per a day with 80 to 95% methane. Cronian and Low examined UASB reactor performance in terms of treatment efficiency and methane production under different hydraulic retention times and organic loading rates. They found that as the COD loading rate increased with time, the influence of the amount of seed material used became pronounced and that a period of at least 2 weeks was required to prevent delays in the startup when activated sludge was used as seed material. So guys, today, just we successfully we completed in unit one. I want to remind these all things what we learned in unit one again. Here, industrial water quality and quantity requirements for boiler and cooling water, process water for textiles, process water for food processing, process water for brewery industries, and processing water for power plants, and process water for fertilizers, and process water for sugar mills. These all things we studied in our unit 1. Next class, I will start second unit 2. Thank you guys.